So here, what I can say here is acceleration is change in velocity by time we discussed. Now let us enter into what is a deceleration. Deceleration. What do you mean by deceleration or retardation? Deceleration or retardation means, yeah, simple word I can use that. It is nothing but negative acceleration. Negative acceleration. Negative acceleration is called as retardation or deceleration. Negative acceleration is called retardation or deceleration. Now, negative acceleration, that is minus a. That means simply I can write in this form is minus a. So here, what is the difference between negative acceleration and positive acceleration? Acceleration means it is velocity is increasing with respect to time. Acceleration is nothing but a. Acceleration is nothing but velocity increases with respect to time. Velocity increases. Velocity increases with respect to time is called as acceleration. If at all, what is minus a? Minus a, it is nothing but it indicates that deceleration. Velocity decreases. Velocity decreases with respect to time. With respect to time. The value of velocity increases with respect to time. Graphically, how to give the information, sir? Means, yes, we can give graphically information also like that. Suppose this is a velocity time graph. If you draw like this the velocity is increasing with respect to time and velocity is decreasing with respect to time. Initially more velocity and its value is going on decreasing with respect to time. Value is going on decreasing with respect to time. It is a retardation. This is called as retardation, retardation, retardation or deceleration. Deceleration. In a simple word, both are same type of quantities. Acceleration, deceleration are same type of quantities. The difference is here acceleration means velocity increases with respect to time. This is acceleration. Here velocity increases with respect to time. Here velocity decreases with respect to time. Like that we can conclude better. So I hope you understood the difference between acceleration and deceleration. Now let us enter into the now about equations of motion. Equations of motion. What is the topic related to the equations of motion means? Here basically what we have the formula means one formula. Let us first start our journey with acceleration formula. What is acceleration means? From definition itself, we know that acceleration is nothing but change in velocity by time. Change in velocity by time. Some student is asking doubts. What is your doubt, beta? What is the doubt? You can chart. V is equal to U plus 80. V is equal to U plus 80. This equation of motion we got from that acceleration definition. V equal to U plus 80. Yes, beta. One student asking me the doubt. What is your doubt? Again, chart. Sir, acceleration is a scalar. No, beta. Acceleration is a vector quantity. Already I mentioned. Already I mentioned also. Acceleration is a rate of change of velocity. Change in velocity by time. It has direction. It has direction, magnitude. Obeys laws of vector addition. So acceleration is not a scalar, beta. I have explained that one also already. I'll show you the pages. So here itself I mentioned that acceleration, the first page itself I mentioned acceleration is what type of quantity means vector quantity, vector quantity, because it is not rate of change of speed, it is rate of change of velocity. Velocity is a vector quantity. So already I mentioned my first page itself, starting line, acceleration is a vector because change in velocity, velocity means vector, vector by scalar is a vector. It has direction. It has direction. This is the first page I started with. Okay then. Now coming to this one, equation of motion. Simply we got here A is equal to, Beza, I will show you all pages. Please don't worry. Let me complete one more page and I'll come back and I'll show you all the pages. So acceleration means V minus U by T. V is equal to U plus AT. Next. Second one. Here in the second point, what we have here means in second point, we have to discuss, we have to know that constant acceleration. Whenever we observe constant acceleration, what do you mean by constant? When a body is moving in a constant acceleration from one point to another point, U and V, in a time t, the displacement traveled is S. It's the acceleration is constant. Acceleration is constant. So acceleration is constant means, then we can write this equation as what is the displacement means. Displacement is average velocity into time. Displacement formula, average velocity into time. When it's moving with constant acceleration, average velocity can be written as average velocity is nothing but U plus V by 2. U plus V by 2. So the displacement formula I can also write it as U plus V whole by 2 into T. S is equal to U plus V by T into T. Here you have to observe one important point. I mentioned here it is constant acceleration. Constant acceleration. Constant acceleration. Initial velocity is U, final velocity is V, and displacement S and time T. So displacement is average velocity into time. Displacement is average velocity U plus V by 2 into T. Average velocity U plus V by 2. And this is a very, very important equation, beta. So many times our work will become very easy with this formula. Sir, is it not S equal to UT plus half AT square? Yes, S is equal to UT plus half AT square is also there. We'll check it out, that one. First, we discussed two things. In previous page, if you observe, in previous page, V equal to U plus AT we observed. This is from acceleration definition. Now this one we observe it as constant acceleration means displacement is average velocity into time. Average velocity. What is average velocity? Displacement by time. So displacement by time means we know that from our childhood onwards, what is average velocity formula? Total displacement by total time is average velocity. So what is average when body moving with constant acceleration means initial plus final by 2. So I can write like the formula in this way. This is about when the body is moving with constant acceleration. All the equations of motion, what we are waiting for? Constant acceleration. So let us see what are the pages I discussed. Today, this is my first page. So if anybody want to take the screenshot, we can take the first page screenshot better. This is my first page. Just 1 minute better. First page it is. Just 1 minute. Just 1 minute better. I'm connecting. Next, this is the second page. Second page, you can take the screenshot. Next, this is the third page. Next, fourth page. Next, fifth page. Sixth page. Seventh page. Eighth page. Ninth page. 10th page. 11th page. 12th page. So these are the formulae what we discussed now. Let us go for the third one. Third one. So now I am removing all these pages better. Just 1 minute. So now here we discussed about 2 points. Next point, let us check it out. Here in the next point, what we are going to discuss is about the third one is just now we observed displacement is average velocity into time u plus v by 2 into t. And one more thing, just now what we noticed means a is equal to v minus u by t. A is equal to v minus u by t. So from this equation 2 into s by t, 2 into s by t is called as u plus v. And again one more equation what we have beta, that is s is equal, that is v is equal to u plus at. V is equal to u plus at. From here I can write v minus u is equal to at. So v minus u is equal to at. 2s by t is also equal to u plus v, like that we have. Now, if you multiply these two equations, equation 1, equation 2, let us multiply these two equations. Equation 1 into equation 2. So, v plus u into v minus u. If you do here, v plus u into v minus u, we can write it as, what is v plus u beta? If you observe what is the v plus u here, 2s by t, v minus u, at. So now combining those two things here, 2s by t into a into t. So t get cancelled. Here I can write v square minus u square is equal to 2as. This is my equation of motion. One more equation of motion what I know is v square minus u square is equal to 2as. This is the formula what I know. So v square minus u square is equal to 2as I got. Already I proved v equal to u plus at, v square minus u square equal to 2as. Like that I got this formula. Now let us check the next one now. Let us check the next one, fourth one. In this fourth one, just now what I discussed here is a is equal to I have v minus u by t. And now v square minus u square is equal to 2a plus a is. So in the both the things I want to eliminate v. Suppose let me take here instead of this all the things. Let me take here v is equal to u plus at. Here let me write v is equal to u plus at. And displacement is equal to average velocity into time. There also what I have beta. This is my first equation, v is equal to u plus at. And second equation I am taking, displacement is average velocity into time. Displacement is average velocity into time. So from here what is the value of v? From here what is the value of v? So here what is the value of v means I can write it as 2s by t, 2s by t minus u is equal to v. So I got the v value in the both the cases. Here v value is 2s by t minus u. And here this is the value I got. And here I got this value. So in the both the cases, if you observe, the value of u v is same. V is same here and here. So as v is same, what I can do now from these two informations, I can write u plus, that is 2s by t minus u is equal to u plus at I can write. So next step to this one. Again I'm writing in the next page, better you check it out. So I just now I written 2s by t minus u is equal to u plus at. So now 2s by t is equal to u. If you send other side, it will become u plus u, 2u plus a. And send 2 and s that side, s is equal to 2u plus at into t by 2. If you multiply this one, finally I am going to get s is equal to ut plus of at square. So this is the formula for displacement. Displacement is ut plus of at square. So like that we got these equations of motion. So is these are equations of motion beta. Let us check now what I discussed till now. This is my first page. If anybody want to take screenshot, you can take. Sir, how we got off, sir? I will show you better. Just 1 minute. I'll show you how you got off. Just now you first take the screenshot of this page. First page. Next page. Next page. This is my last page here. So in this one student is asking me, sir, why you got off? You see, beta, there nothing here. S is equal to UT plus AT. Just here what I did here. 2U, no, beta, minus U I sent this side. Minus U came this side, means minus U plus U, 2U. And then what happened? AT. Yeah, 2S by T is there. T and 2 both I send other side, T and 2. So T will come to the numerator, 2 will come to the denominator. Multiply T by 2 here. 2 cancel. UT off. This T off is there, no, but T by 2 multiply for this part. So off AT square. Off AT square. I hope it is clear how I got this expression. Any doubt till here, beta? Is it clear? Yes, fine. So again, our main concept is about mainly we have to concentrate on the displacement in nth second. Our main target is SN. SN formula. What is the displacement in nth second? Formula for displacement in nth second. What is the formula for displacement travel by the body in nth second? Nth second. So for this, our target, what is displacement travel in one particular second? You have to analyze one information for to understand this one. Suppose a body travel like this. So this is the first part. Suppose this is from here to here in suppose 1 second. 1 second it travel. From here to here it traveled in 2 seconds. From here to here it traveled in 3 seconds. Only this part, only the part I am taking this one now. Only in this part means what should I say? This is displacement in third second. This is the displacement. Here displacement in first second. Displacement in 2 seconds. Displacement in 3 seconds. Now this is displacement in third second. Third second. Third second alone. Third second. So third second, one particular second we are taking here. This is 1 second. This is 2 seconds. 2 seconds. We are writing it as 2 seconds. 2 seconds. Here we are writing it as 3 seconds. But here third second. So this is different now. Third second is different. So we have to analyze the formula for this one. This formula for universal formula. What is the universal formula? From here in this diagram, you can simply say, actually from this diagram, I can say that displacement in third second is nothing but displacement traveled in 3 seconds minus third second you are taking twice, sir. Yeah, I'm writing that is displacement in 2 seconds. I didn't get you better. Some doubt somebody asked, I didn't get. So let me check. So here, third second you are taking twice. Third second you are taking twice. Where did I take twice here? Third second, I didn't get you that one, beta. This is 3 seconds. This is 3 seconds. This is third second. Third second means only from here to here. 3 seconds from starting to here, 3 seconds. From starting to here, 2 seconds. Only between 2 seconds time after to third second time, 3 seconds time is from here to here is called as third second. So what I concluded here formula, third second is nothing but 3 second displacement minus 2 seconds displacement. Very, very, very important and very simple here. So here from this, what is the SMth? So in third second, it is having two different displacements. Not in third second, beta. You please differentiate this one. It is not third second, 3 seconds. 3 seconds means from starting to here 3 seconds. One student is unable to understand, no problem, beta. I will show you. So Let me analyze this one better for you. So from here to here, from here to here, displacement in first second. From here to here, displacement in first second or 1 second, both are same. First second or 1 second, both are same. First second or displacement in 1 second. Displacement in 1 second, both are same. First second or 1 second. But now displacement, this one is in 2 seconds. 2 seconds. Only this part is called as displacement in second. Second. From here to here is, this is called as displacement in 3 seconds. 3 seconds. But only from here to here it is called as displacement in third second. So again, from here to here it is displacement in 4 seconds. Displacement in 4 seconds. Now if you observe here, only from here to here, it is again displacement in fourth second. Like that we have to analyze better. I hope it is clear now. Now my formula, what I need is, sir, are the displacement in first, second and third seconds? Some question I didn't get you. 1 minute better. So are the displacement in first, second and third second equal to each other? So it will depend. That means it is not same. Why it is accelerating? It is accelerating. It's not same. In second, because if it is not accelerating, is moving with a constant speed, then first second, third second, fourth second, constant speed, same. But it's not constant speed. It is acceleration. Acceleration is there. Acceleration, it is not same. We can't say it is same better. I hope it is clear till here today. So in next class, I will discuss the further part, which is main parts. I'll discuss in my next class. Today I am ending the class beta. Again, I'll meet you all people in my next class. From tomorrow onwards, I'll plan the maximum number of classes I will take, and I will make you to clear all the topics. So I'll handle from tomorrow onwards. Again, this first year class as well as second year. Thank you everyone. We'll meet tomorrow. Thank you, beta.